Okay. So the first thing we kind of talked about was, how do you know if a number is rational? What makes something rational? What could we have? What's something? A fraction. Any kind of fraction number is irrational, so like 1/3. What about the number like this, 15? Does that work?
Yeah.
Is that a fraction?
Yeah.
Yes, technically if I really wanted to write it as a fraction, it would be what?
15/1.
15/1. What about this?
Yeah.
Yes, still a fraction, still good. Okay. What else can we include as rationals?
Yes.
Decimals. So something like this, 0.72. Is that good? Yes, that's a rational.
Certain.
What kind of certain decimals? What other kinds of decimals are good? Kogo, what did you say?
I thought like the ones that repeat.
Ones that repeat. So for instance, 0.33333333. Is that good?
No.
Yes.
Yes.
Okay, tell me things that don't work.
The decimals that go on and on and on. Like
Pi.
0.14.
Non-terminating. Is that a word that you like? Non-terminating decimals. Or non-repeating as well, right? So somebody said pi over here?
Yes.
3.14. Anybody know the next decimal?
159,265.
Something forever. What other ones also usually are categorized there? What other kind of values that we've seen?
Like 12 over 0.
Okay, that's a different. We'll get to that last. I like that. We're gonna get to that. It's its own category. What you just said.
10 divided by 3.
10 divided by 3 would fall into the repeating.
Oh.
Yeah, so then that would be good. What other things don't ever really stop? What other kind of numbers do we run into? 0 is good. 0 is still in here. 0 is a fraction. What about that value? The square root of 5. What would you know if you were to put it in your calculator?
That's like
When
2 point
blah 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 blah. Doesn't stop.
6, 0, 6, 7.
Okay, it doesn't stop. So it's 2 point something something something. Okay, and Annika mentioned one more thing. She said, well, what about something like this? 12 divided by 0. That is also not rational. So this was not irrational. This is not irrational. And why is that not? It's undefined. It can't exist. The word is undefined. You can't divide by 0. It's just one. It's its own category. You're going to like feature that all of grade 12. Okay, you're going to have to do comparing numbers. And I'm going to use this word called descending order. Bless you. Okay, so get ready to compare. I'm going to throw in decimals, fractions, mixed. So you're going to have to compare things against each other. FYI, on this test, you are not going to have a calculator once.
So no.
No calculator. You can do it.
It's like in
You
the
have a calculator in your head.
future life you'll have actually.
Okay, first of all, you got to understand this word. What does descending mean? You're going down. So we actually have to start with the biggest. So for me, there's 2 positives and 2 negatives. So for sure, a positive number is going to be bigger. So which one of these is bigger?
1.3.
1.3, because you should have this 1/4 memorized as a decimal, which is 0.25, so 0.3 is bigger. So 1.3, then 1 1/4. So I am going to take these and kind of both compare them to a half. So what would you think about this one?
It's closer to a hole than a
It's closer to a whole than a half, and this is less than a half. So which one is actually a bigger number then?
Not 4.
This one is bigger than this one because now it's going more negative. Okay, you are going to have to know decimal stuff. Okay, what if I did something like this? 8.16 plus 10.4. Okay, so what's important is that you stack them, and when you stack them,
It's 18.5. So you're adding the tenths.
okay, so here's the important thing with decimals. You need to make sure place values are in columns. Okay, so the 1 is its own column because it's the only thing ever in a 10 position. The 8 and the 0 are both 1 position. The decimals are on top of each other, the tenths. Okay, so everything always has to be lined up. Decimals. Okay, same with subtraction. Make sure you're lining that decimal stuff up. Okay, what about timesing decimals? Okay, so when you are doing decimal multiplication, okay, we just forget about the decimals. No decimals needed, and you just multiply the numbers. So 18 carried, 6 with a 1 carried. Make sure you leave a place value spot. 24 carried. 8 and 2 carried. Okay? You should know that this isn't the answer because think about 2 something times 4 something. Well, 2 times 4 is 8, but I'm bigger than 2 and I'm bigger than 4, so I'm obviously a little bigger than 8. Okay? How many decimals should my final be? So if there's 1 here and there's 1 here, my final should have 2 spots after the decimal. And that's 11-ish, makes an estimated sense, right? Okay, what about division? So I'm just gonna undo what we just did. So we know the answer is what? What do you know the answer is right now? 4.3. That's the answer, right? This times this is that answer. So this divided by that is 4.3, right? So we know the answer. So how do we set this up? Okay, so setting this up. I do not want decimals in this number. So what would I do to eliminate decimals? Move it 1 place. I only have to move this 1 place. So if I move this 1 place, I'm going to move this 1 place. Okay? So that's the strategy. So this number in the front here, make sure you get rid of the decimals by moving or timesing the place value by 10 or 100, whatever you need to. Do the same thing here. I have a decimal here and that's fine. Okay, how many times does 26 go into 1? Doesn't. 11 doesn't. So my first is 26 into 111. So I'm going to do it 4 times because I know 4 times 25 is 100. Okay, so 4 times 25 is 100. What's 4 times 26? 104. And that leaves me with 7. So I bring that down. Since I had a decimal there, I have to line that decimal up there. And then how many times? 3. 3 times 25 is 75, right? 3/4 is 75, and 3 more. Okay, but it was all about that movement of the decimal number. Okay, positives and negatives. Do you know your stuff? Anything that's positive times positive is positive. What about a negative times a negative? Positive. What about a positive divided by a negative? Negative. Okay, division and multiplication are the same rules, right? Okay, you got that down pat? You're gonna see fraction stuff. That was me. That was a big one. Okay, so fractiony stuff. What do you do if you're adding or subtracting decimals or fractions?
Common denominator.
Common denominator.
Flipping is reciprocating, which is division.
Okay, so I need a common denominator. So there's a 3 and there's an 11. So I'm turning the bottoms both into 33. Okay, somebody help me out here. What happens when I subtract things? What do I actually want to do instead? Add opposite. So I would add really a positive, right? Okay, so we know that 2 subtracts are really the same as an add positive. Okay, let's times this by 11.
22.
Negative 22. We'll keep the negative on that one though, right? And we'll times this by 3, so 15. So what do you do when there's 2 integers and they have different values? Should I add or subtract their numbers? Subtract. So what's the difference between a 22 and a 15? 7. More negatives or positives? More negatives. Okay, we'll do a division question. I'm also going to throw in some mixed fraction stuff. You're going to have all sorts of fraction. Okay, so let's change this question to be improper. So 1 entire pie with 4 pieces. So that's 4. 3 more. 7. Just leave it with divide. Just leave it divide right now. 2 pies with 5 pieces is 10. 1 more. 11. Okay, so that's going to be your step 1. You got to change that to be improper. And now is where you times and reciprocate. Okay, so how do we fill? But we got decimals, we've talked about integers, we've talked about fractions. Okay, let's talk about radicals and exponents a little bit. Radicals and exponents. I'm sorry, are you running out of room on your page? How much more should I talk about? Okay, what is the value for
How many zeros is that?
1, 2, 3, 4, 5, 6, 7 zeros? Okay, so first of all, I need to do 2 things here. I need to understand how many decimal places I'm at. So there was 8 decimals. So the square root is me understanding something squaring to get to that. Something squaring means multiply, multiply. So it has to be the same thing and go to 8 decimals. So I need a 4 decimal and a 4 decimal. So I need something with 4 decimal places. And then,
Is 003? 003?
okay, so the 4 decimal is the one that gets me to 8 decimals. Easton, are you distracting every single person around you in the radius of your tables? Okay, and just likewise, what's the square root of 10,000? Okay, so I would do this. What's the square root of 1? 1. How many zeros? 4 zeros.
For 500.
So I need 2 zeros.
Sorry.
Okay, I have like 2 questions left then maybe. I'll just do this one. You'll have room. I have 2 little small questions. Estimate. Okay, so I need you to have your perfect squares. Perfect squarables. Memorize. Okay, can you give me a perfect square that's just below this?
Isn't it like the 49?
49 is below it.
64. I like your new clock, by the way.
Thanks, it just went up 10 minutes ago. Okay, so the square root of 49 is 7. And Annika, would you were willing to give one? 64 is a perfect square above it. Okay, so do you understand this value has to be between 7 and 8? So it's going to be 7 point something. What do you want to lean towards? The number line towards 7 or towards 8?
8.
Towards 8, we're a little bit higher. So 7 point, and I need your estimate to be on the 7.5 above side.
7.8.
7.8 is a good answer. 7.7 is a good answer. Anything really in that little zone. Okay, and I'm only going to ask that to be 1 decimal place. That's good. And likewise, we're going to do something like this. 4.8 squared. So this is kind of the opposite process. Estimate. Okay, so I need you to go below. So the below is 4 squared, 16. And I need you to go above, which is 5 squared, or 25. So 4.8 is in between 4 and the 16 and the 25.
20 or 21.
And I would say we are closer to here. So you're thinking 20-ish? Is that what you're thinking? So on your test, when I say estimate, I say include your work. This is me showing you my work. Okay. Do you understand how to tell if something is square rootable? Is it a perfect square? Is it a perfect square? So something like this. Is that a perfect square?
Oh, yeah, I don't know.
Yes, it is. Why? 4 is a perfect square. 25 is a perfect square, so it's good. I can square root it. That's a perfect square. Is 1/8 a perfect square? No. 1 is a perfect square, but 8 is not.
Well, it is, but, oh, no, you still need decimals.
Is this a perfect square?
Yes. You can divide it by 3.
No.
Oh, dang.
I tricked you all. I knew I would. It's not a perfect square.
Because it's point.
How many decimal places does it have?
Oh.
3 decimals. So each one would have to have 1.5 decimals? Question mark, not possible? So then it's not.
Imagine if there were decimals.
Okay.
If there were 4 decimal places, it would be.
Is this square rootable?
Yes.
Perfect square?
Yes.
Yes.
Oh.
No, but yes. What about this?
Yeah.
Yes. This has 2 places, this has 4 places. So that's good and that one's good, but can't hear. Okay, I really tried to trick you. Okay, does anybody feel like, I don't know, do you remember your word problem? You're like a quarter of your budget. Remember that question?